Why do dependent systems of equations representing the same line? Imagine looking at two different recipes that turn out to be exactly the same dish. Even if they look different at first, they are really just the same thing in disguise. That's what happens with dependent systems of equations. When you see two equations in a system, and they are dependent, they are actually describing the same line. A dependent system of equations is made up of equations that are just multiples or rearrangements of each other. For example, if one equation is y equals 2 times x plus 3, and the other is 2y equals for x plus 6, these are really the same line. The second equation is just the first one multiplied by 2. When you graph both, they overlap perfectly. They lie right on top of each other, showing the same set of points. Think of it like copying a picture with a different size or orientation. The picture is still the same, just presented differently. That's what happens with dependent systems. They do not give you new information. Instead, they confirm the same relationship between x and y. When you look at the slopes and intercepts, you will see they are identical. The slope tells us how steep the line is, and the intercept shows where it crosses the y-axis. Since the equations are multiples of each other, they share the same slope and intercept. So, graphing them results in one single line, not two separate ones. This is why dependent systems of equations have infinitely many solutions. Every point on that line satisfies both equations because they are really just one and the same. Recognizing this helps you understand that the system isn't giving you two different lines, but just one line described in two ways. In summary, dependent systems of equations are made up of equations that are scalar multiples or rearrangements of each other. Graphically, they form the same line because they describe the same set of points. The solutions to these systems are all the points on that line, making the system have infinitely many solutions. Knowing this helps you quickly identify when equations are dependent and avoid unnecessary calculations.